Hi, my name is Liang Zhou Koh. I'm a graduate student in philosophy at the University of Toronto, and today I want to talk to you about common knowledge. One distinctive aspect of human mind reading is our ability to entertain and reason about higher order knowledge and belief that agents may have about the mental states of others. In other words, our ability to have knowledge and belief about what other people know and believe, not only about the world, but also about other minds. In this video, we'll be exploring an important social phenomenon that is closely tied to this advanced mind-reading ability, common knowledge. We sometimes call something that is widely known by everyone or almost everyone in our community common knowledge. Paris is the capital of France, or water is H2O, are some examples of this kind of common knowledge. Common knowledge, however, is also a technical notion that is widely used in philosophy, economic theory, theoretical computer science, and linguistics. According to a classical definition, some agents commonly know some fact. If they all know it, they all know that they all know it, they all know that they all know that they all know it, and so on, infinitely. Why should we be interested in this phenomenon? Common knowledge appears to play an important role in underpinning social coordination. One classic case for thinking about this function of common knowledge is the coordinated attack problem. Imagine two armies camped on separate hilltops, preparing to attack a fortified city the next day. They can win the battle only if they attack the city simultaneously and will suffer a defeat if they fail to coordinate their attacks. Unfortunately, the battlefield is shrouded in a thick fog, and the only way that the generals commanding those armies can communicate is via messengers. Moreover, since it's possible for their messages to be captured by the enemy, there is no guarantee that the messages will reach the other general. Let us consider what it would take for the generals to coordinate their attack. Suppose General N sends the message, "Attack at dawn," and General Bill receives it. However, since N does not know if Bill received the message, it would not be rational for her to risk a catastrophic defeat and command her army to attack at dawn. Knowing this, it would also not be rational for Bill to attack. Suppose Bill tries to improve their situation by sending a message back to N, confirming that he has received her message. Since Bill does not know if his reply reached N, he does not know if N now knows that he received her initial message. It would not be rational for him to attack. Therefore, even if N does receive Bill's reply, since she knows that Bill does not know that she has received it and would not attack, it would not be rational for her to attack either. Suppose N sends another message to let Bill know that she received his message. The same line of reasoning should lead us to conclude that doing so would still not allow them to rationally coordinate. It would appear that no matter how many messages they sent, it would not be rational for the generals to attack. Let us now put things in terms of what the generals know. Consider what happens after N sent the initial message to attack and Bill received it. Since there's a chance for a message to be intercepted, N does not know whether Bill received it. Suppose, after waiting for some time, she receives Bill's reply, and would now know that Bill received her message. However, since Bill does not know whether his reply reached N, he does not know that N now knows that. Suppose N sends another message to acknowledge that she received Bill's reply. Once Bill receives this, both N and Bill will now know that they both know that Bill received the initial message. However, since N does not know that her latest message got through, she would not know that Bill now knows that she knows that he received her initial message. We may extend this line of reasoning indefinitely. Recall that, by definition, for N and Bill to commonly know that Bill received the message to attack, they both need to know that the other person knows that Bill received the message, and so on, infinitely. In this scenario, however, the unreliable channel of communication makes it so that there will always be one level of knowledge in this infinite series that the person who last sends a message will fail to attain. Thus, the generals will not attain common knowledge that Bill received the message to attack, no matter how many messages they sent. This absence of common knowledge may explain why rational coordination is impossible in this case. But it also seems wrong to say that the generals would not be able to rationally coordinate their attack, no matter how many messages they send. Intuitively, it seems rational for the generals to commit to the attack after they have exchanged a certain number of messages. Suppose the generals manage to successfully exchange 5 messages between them. Imagine how it would be for Bill to then reason as follows. Anne does not know that I know that she knows that I know that she knows that I received a message to attack, so she will not attack at dawn. Therefore, I should also not attack. When put in this way, Bill's reasoning does not seem so compelling. The general's decision to not attack would seem even more bizarre when we go from 5 messages to, say, 27 messages. This conflict between our intuition and the line of reasoning that we've just sketched is at the heart of the paradox of the coordinated attack problem. In the next video, we'll look at some responses to this paradox.